Well, hello everybody. Welcome back to the Golang tutorial, lesson 4. Now, I've been working through and preparing some of these lessons, and as I was doing that, I came across an idea about teaching programming, which I think might be helpful. This was largely from seeing a bunch of videos called How to Think Like a Programmer. The videos are good. I'll send you a link somewhere. Check them out. But I'm going to try and incorporate some of that into what I do too, because it's important to think in these kind of ways. I probably won't be watching him very directly and following, but it's important to get that idea that there are ways of problem solving that we need to do. And as programmers, we do these all the time. Once I've been programming for so long, you just think about these things naturally. But if you're new to programming, it's hard to get your head into the ways of thinking that make solving programming problems work. So I'm going to try and focus a bit more on that in each of the lessons to help you going. Today we're going to continue the higher-lower game, and doing this should teach you about the for loops. We started last week with a for, but there's way more that they can do. Binary searches, which are actually the best way to play higher and lower, but they're very, very useful in all kinds of programming situations, and we'll come across that and explain more about them as we do the game. And random number generators. So, how did we do with last week's challenge? Let's have a look, shall we? Oh, I didn't tell you, I'm back in Linux now. I'm way happier here. So, oh, and if you get around to it, like and subscribe these videos. What was the name? Lesson 3 we were working on before. So, lesson 3, we have our function for askInt, which loops around using this infinite loop until we get an answer we're happy with, i.e. there is no error in the line in trying to convert the string to a number. We have our main function here, which just keeps going. And I wanted to ask you guys, or I did ask you, to write a function or a program. I think I said program, but it's just as well to stick it in a function of its own. So, and then you can call it or not. So. And this function was going to print all the line numbers up to 100. So I'll call it print to 100. Open bracket, close bracket. We can do way better than that with our little function. But for now, we're going to start with our print to 100. And now we were going to make an counting variable. So var I int equals 0. You could probably just write I colon equals 0. It will handle that very tightly and just say that that's an int. Default's right. So I is 0, 4, and we just did our loop like this. And inside the loop, we can put I equals I plus 1, and then funct.print line, or printf and then put the quote, but I'm just going to print line I, and here our exit condition, if I is equal to 100, return. Now that should do our print to 100. I'm going to go here and I'm going to call the function here, print to 100, close bracket. And then it will still play the game as well, and we'll come back to the game in a minute. So, back over here where we run our code, go run lesson3.go. So as you can see, all of the numbers there go from 1 all the way up to 100, and then it's carried on with the program because I just stuck that function at the top. Take a guess. Well, I know its number's 35, don't I? Because we didn't do anything to make it a bit trickier. So, we've done that. Now we're going to give him a random number. Now the thing I forgot to do before starting this lesson was actually check that I know what the random function's called. I spend most of my time looking. And actually, here's the thing you're going to do when you're programming. You're going to have to go to the libraries from time to time. So where are I? Firefox. Because I don't always remember all of the functions that are available. But that's okay. There's tons of functions. You can't be expected to remember them all. You can be expected to do... Oh, it's opening here. I left it too long in the wrong place. You can be expected to know where the libraries are and to go and read them from time to time. So here we are, golang random int. I'm pretty sure there's a straightforward golang rand. Here's our library. So I've got to import math.rand. So let's do that at the top. Oh, is that the one I want? Yeah. So here we go. So if I import math, I said dot, didn't I? It's a stroke like that. And if we go down here, I'm pretty sure. Do we need to seed it first? Let's see if we can. Random numbers are generated by a source. Top level functions such as float int use default shared source that produces a deterministic sequence. So what that's saying is, if I just use the top level function, I'm going to get a random number, and I don't need to seed it myself. It'll seed itself happily at the beginning. So that's okay. So if I just type, I'm pretty sure the function is rand.intn is this one. I mean, you get used to reading through these, but this is the one I want. So intn returns an int as non-negative pseudo-random number between 0 and n. I think that bracket means it's including 0 and not including n, so the number's going to be less than n. It panics if n is less than 0. That's fair. We're not going to give it a number less than 0. So we've got our rand thing, so that now means we have a function available. And where we put 35, we're going to change this to rand dot, the function that belongs to rand we access by using dot, and then it's a capital I N T N, open bracket, and the highest number is 100, right? Let's get rid of this line as well. We don't need that anymore. So now he's thinking of a random number between 1 and 100 in theory. Let's move this to another workspace. We might need it later. Over there. And come back here and run our program. He's thinking of number. Now, last time we thought it was 35. Do you think we'll get it right on 35? Nope, it's higher. Okay, so higher than 35. Try 70. Nope. It's higher than 70. Let's try 90. Lower 80. Higher 85. 83. 82. 81. I got it. Okay. So the program has done the right thing. The answer was 81 and it's worked us through, so we were able to play the game. I guessed it very lazily. Probably should have started with 50, but that's the point in ran in the binary search, which we're coming to now. So we're going to make it now so the computer has a turn at guessing our number. So how do we give the computer a chance to guess our number? Well, we need to have a function that will ask us whether it's got our number or it's higher or lower, right? And I think we should use a similar system to what we used from our scanner before. So this function will now be, I have a feeling I want to make this function a bit more usable than just here. There's a reason for that. I'm actually thinking of making a package, and that will happen in next lesson. So I'm going to make this function able to take a list of strings, and it can choose one of them and give an appropriate response. Oh, it just says I won't give a response unless it's one of those. So, new function, and this is ask set. Our problem with this, of course, is that I haven't yet told you about arrays. I was going to teach about for loops later, so we won't worry about this too much. We're just going to ask for yes and no. Ask yes, no. We'll talk about arrays sometime soon. Ways we do lists. But we need to be able to ask yes or no. Is my number? No, it's yes, higher or lower. Higher, lower. Right, they're the three answers that a human can possibly give. And this will return an int, I think, and that int will be -1, 1, -1 for lower, 1 for higher, and 0 for yay, you've got it. So scanner colon equals buff io dot new scanner, and it will take os dot standard in. Honestly, I would have had to look this up again, but I'm just reading the code from directly above 4, and we're doing a for loop. It's better to type it yourself again, because if you try and copy and paste and then correct, you're going to find there's mistakes in. Whereas when you're writing the new code, it's good at least to make sure you've written it to cover the new case. Oops. But we do want to do we should take a message, shouldn't we? I think that's a good idea. Message, and that will be a string. Because if we don't have if we have a message, then we can say, we can work with that message and ask again and again. So funct.printf, and again, I think this is basically the same as what we wanted before. %s n, so that's a new line, and then the two greater than symbols to point to where they're supposed to type, and that will be message. Again, we need to read the new line, but this time we're not going to use scanner. Well, we are going to use scanner.text, so we will do that. scolon equals scanner.text, all capital T. But here's where we have to do something different. If s equals yes, we'll do it lowercase. If s equals yes, then what do we return? We return 0. Return 0. If now it won't get here now if s was equals to yes, so but now it's checking for s equals higher, and then we return 1. And if s equals lower, again in string quotes, lower, return -1. We can actually allow a bunch more options here, and I'll introduce another concept as a switch at some point. We have our for loop. It's gonna, otherwise we need to print a message. The message here we need to do is funct.printf please, oops, please only enter yes. Oh, that's a weird habit. We a lot of languages allow this concept called escaping, so you don't know for sure. I need to include a quote in this string, but if I include a quote, that will end the quote, right? And then type something else, it's not in the quote. So if you put a backslash before a quote, then that quote becomes escaped in the same way as we have a backslash n, because if we just put an n, it would be the letter n. What do you do though if you want to include a backslash? It's tricky, but it's not actually that hard. You just use 2 backslashes, and then the backslash after the backslash is the backslash. Please only enter yes, higher, or lower. I should probably put quotes on all of those words. The other option is, of course, to not use one of those quotes. It's inside a big quote. I can use little quotes. And here as well. Okay. We'll put a new line. close the actual quote. So in theory, we can now ask higher or lower, or make a guess of a number. This function here should probably be called, instead of calling it main, we should call this function something else, because this is the one side of the game that works. So I'm going to correct this word and call it keeper, short for secret keeper. So he plays. So this is the one where the game plays keeper, and there's another one where the program keeps func main. We still need a main function. The program won't work without it. But if we have one that calls, if we call keeper and then seeker, and we make another function called seeker, and then we can code the two games actually separately and play them both, because it's actually quite a different game to play seeker than it is to play number keeper. So what do we need in this function for our seeker to work? How are we going to have the computer guess numbers? Now, I've introduced a new concept. Hopefully you can see its use, but we'll give it a go. So we'll put in a for loop, because he's going to be guessing. I guess it's first think of a number. Have you thought of a number? And then if he pushes enter. Funct.println think of a number. Or we can do this in a message. We'll use the yes no message. And you'll be say yes when you think of a number, because that's the only answers it can give, but it just means I don't have to write so much code. So what was it called? Ask yes, no, higher, yes, higher, lower. See, that's another reason why having ask set would have been in good. And the message will be say yes. We'll put that in quotes. When you think of a number. We should put seeker first, actually, because we'll be able to test our code better that way. In fact, we'll pull off keeper for now. I'm going to do something I haven't shown you yet. Really handy. That's 2 forward slashes. That's called commenting. Anything that's behind comment is ignored by the compiler, but lets you read that. I normally mean to do this more. Every programmer means to do this more. Very few programmers put comments in correctly. So I'm going to show you what I've already done in my mind, and what's a really, really good habit to get into is to think, okay, so what am I going to do? First, ask the user to think of a number. And then in comments here, loop to keep guessing until we find the right answer. Yep. And by putting those comments in, actually you can help yourself to write your code quicker. If you can describe in English what you want the program to do, instead of simple instructions in English, then maybe it will make it easier to write your code when you come to it. I always had this problem. Even as a kid, I refused to write my working. I always just went straight from the beginning to the end. And it's taken a long time to learn to do this properly. So, ask, yes, higher, lower. Say yes when we think of a number. That's not ideal, but it at least gets us to a point where they've thought of a number and they've pushed a button to say, let's go. So now we can start guessing their number. So we're going to put it in a loop, just like this. And inside this loop, we will choose a new random number, I equals rand dot int n. Now the colon equals, of course, is how we define it without saying what type it is, because Golang knows what type int n returns, and so it says, well, it's going to be an int then, isn't it? And this will be between 1 and 100. Oh, and we should probably say between 1 and 100. Int n. Now if they're thinking 1 to 100, this is going to return 0 to 99 random int n, so we can add 1 to that. So we're going to just guess a random number, and they'll respond higher, lower, right? But if so, the first thing we do is ask. Ask yes, higher, lower. Is it I've put the message here, and I was thinking of putting the message inside this text, but of course a number isn't a string, so I can't just throw it in the string, except if I use fumt, if I want to throw it in the middle of the string. The other option is, of course, if I go like this. We have the converter, don't we? So I can convert string convert I to A. Is it? So I'm going to use that plus str convert dot. So we have the A to I method, but there's also a method called I to A, and that converts from an integer to a string. So I can put I in here. So the string gets added all together, quote, question mark. So when you add strings together, what it does is it sticks the one string on the end of the previous string and then the next string on the end of that. Should probably suggest some answers. Yes, lower, or higher. Just like that. And the next thing we should be able to get, oh, we get an int result from that, don't we? So res colon equals, so that's the result from this function, and if that's a 0, we've got it right and we can return. So if res equals 0, return. Oh, we should probably say something like a yay. Fumt.print line yay. So, can you follow what we've done here? We've used the for loop, for, and we've just put I to a random number. This loop will go forever if the computer never guesses it correctly. Maybe this could take many, many guesses. Can you see why this will take so many guesses and is not an awesome strategy? It is perhaps the most obvious way, because this is how when you ask a kid to play the game, this is probably what they'll do. They'll just pick random numbers. But we'll do better. I'm going to run this code and then we'll see if we can do better. So if I call over here, go run lesson3.go. Say yes when you think of a number. So I say yes. Yes. Is it 82? Yes, lower or higher? I didn't think of a number. That's true. I can always just leave by saying yes, can't I? So it wasn't. It's lower. It's going to be 50. Okay. Lower. 88. See, it didn't know to go lower. It went. So if I say something that's not, if I say Joe, please only enter yes, lower or higher. Higher or lower. So it's asking, is it 88? The answer's lower. Is it 48? Higher. Is it 60? Lower. Is it 82? Well, we know it's lower. See, this is the problem with random numbers and why it's terribly inefficient. I'm just going to say yes because that gets us out of the game. And now we're going to look at a better way of solving this problem. What if we keep one thing we can do is we can limit its guesses. Now it shouldn't take more than 10 guesses. So we can keep a count of guesses. Colon equals 0. And now here's the fancy part of this for loop. We can actually make it require something. Guesses is less than 10. Now this loop will only begin at the end of 10 guesses. So here we can put funct.println too many guesses. So new thing your for loop has is the ability to only continue. So what is this doing? Guesses is 0. Oh, I need to add 1 to guesses. We should probably do that at the end because it feels more natural here. Guesses equals guesses plus 1. Or shorthand, guesses plus plus. It's very, very common in programming to want to add 1 to a number. So they give you this shorthand when you want to add 1 to a variable. So, got 10 guesses to wait for. So let's run the program again and see what happens. Say yes when you think of a number. Yes. Is it 82? What? It's seeded from the same place? That's funny. Lower. Is it 88? Lower. Is it 48? Lower. So that's why you might want to reseed the random number generator or to create a new random thing. It's because it's always going to start from the same set of numbers and count in exactly the same way. So say our number's 1. I'm just going to keep writing lower until it gives up. It should have kept track of the guesses. Oh, I said 1. Forget that. It's higher. I'm not going to actually give it 1 because I want it to say too many guesses. So we can actually cheat there, couldn't we? So by having that loop that stopped the same, but we were able, instead of where we did it with a return, if guesses was too high, we could actually make sure it only checked in the for loop. So when it gets to the end of the for loop, before going back to the beginning, it says, is guesses less than 10? And if it's not, it goes into the loop. And if it is less than 10, it goes into the loop. And if it is not less than 10, it doesn't do the loop and it just carries on where it left off. And so that's how you can carry on with more code. There's actually more we can do for this for loop. You see we've got the guesses, colon equals 0 here. So that's our initializer, that's our first variable. We have our guesses is less than 10 here, and our guesses plus plus here where we increment guesses. So what if instead I put guesses colon equals 0 here, a semicolon in between, and there is a specific order to these. Guesses plus plus. We can get rid of that. So the first one of these is your initializer for your counting variable. So guesses is the number of guesses we've had so far. The next one is our condition. So first it's the number of, it's the first the first value. So when we set it up, we set it to 0. Then we have our condition, which it checks the very first time you do it, and it only goes into the loop if this is true. And then we have our increment, or our change. This could change anything, but the most common way of doing it is to change whatever your counting variable is. So when the code runs, it will get to this point here and go, oh, I'm going to set guesses to 0. Is guesses less than 10? Well, guesses is 0. 0 is less than 10. Okay, let's go in. Runs through the loop. Finishes the loop, and then it goes to the increment and goes, guesses was 0, guesses is now 1. And then it goes back here and goes, is guesses less than 10? Well, 1 is less than 10. Yes. Goes into the loop. And then it goes back here again. Guesses is now 2. Is 2 less than 10? Yes. Runs through the loop. Then I'm sure you get the picture. Eventually it guesses gets to 10 and it goes, is 10 less than 10? 10 is not less than 10. And so instead of running through the loop, it goes to here, too many guesses, and carries on. But we can do better, because this is never going to find the answer we need. But we have a system that will help. Because we already know that if someone has said lower, we don't need to guess any numbers lower. So we have a highest number in range. Right, so highest, colon equals 100. Lowest, colon equals 1, I guess officially, because it's 1 to 100. So the highest number available left in our scope is 100, and our lowest number available in our scope is 1. Now here's the tricky bit. This is how a binary search works, and these are so useful in programming. Actually, I'm still going to use the random number, but we don't have to. Random number's not quite as effective, but it's actually so close to as effective in real terms that it's probably as good to leave it random as it is. In fact, there is one situation where it's actually slightly better to use the random than just to use halfway between the lowest and highest. But a traditional binary search will actually go, in fact, let's do that here. Highest plus lowest over 2. And instead of calling it I, let's call it mid. Okay. So mid is now halfway between highest and lowest. Now, that's better. If it didn't have those brackets around highest plus lowest, it would have done lowest divided by 2 first and then added highest. Another thing that's worth noting, when you do integer division, if I divide 5 by 2 with integers, the answer will be 2. If I divide 7 by 2, the answer will be 3. It won't be 3.5. So it's always going to go to the lower half. So now we know it's going to start with, well, I think it's probably 50 still. 101 divided by 2 should be 50. If I can do math. So it's going to ask, is it, and now it's not I, it's, what's going on here? There we go. Now it's mid, right? I changed that word. Mid. And now's the tricky part, because we can actually change some of our variables. So if it's got it right, then we can leave. If res is greater than 0, then we know that it's a bigger number we're aiming for, yeah? So it's bigger than 50, then the lowest number in our scope is now mid plus 1. Lowest equals mid plus 1, right? Can you see this? Because this is a tricky one to get your head around. But if res, if res is greater than 0, and that means if the answer was higher, then our lowest range is now bigger. So now we're working, so for the first time it does it, it will guess 50. And if I say it's higher than 50, it now goes, oh, well, the number's definitely bigger than 50, so it sets lowest to 51. Okay, hopefully that makes sense. The other is also true. If res is less than 0, highest, and that's the highest bit in our scope, equals mid minus 1, right? Because it's not going to be, we know it's lower than 50. If someone has said, if the response has been minus 1, then we know it's less than 50. And now let's see if this works. It should do. Say yes when you think of a number. Yeah. Is it 50, lower or higher? Well, the number we're going to think of is 35, which is lower than 50. Lower. Is it 25? Higher, because 35 is higher than 25. Is it 37? Lower. Is it 31? Higher. Is it 34? Higher. Is it 35? Yes. And it found our answer. Oh, we do need another condition. What if someone cheats? What if our person just keeps answering a lie all the time? And we need to be able to say, actually, we have found your number. So let's do that. If res is greater, no, if lowest is greater than highest. Now this is a thing. It shouldn't happen if the player is being honest. Oh, those brackets aren't needed. I'm used to other programming languages. If the player is being honest, this shouldn't be needed. So we will say func.printf don't be a cheater. Because that's the point. If someone has done that, oh, let's make that whole line. So let's do that. Let's lie. Yes, we've thought of a number. We're just going to keep saying lower. No, let's do one higher as well. Lower, lower, lower. So our lowest number in range is 25. So if I say lower, it said don't be a cheaty cheater, because it can't go any lower. It's got is it 25? Lower, lower. Yes, fine, it's 25. So it's actually got it correct this time. And it still would have kept going. It would have given up if we kept cheating. I think actually at that point we should just return that function saying. And so that's the concept of a binary search, where it starts in the middle and then goes to either side. And it's really, really quick. You could have 1,000 entries. In fact, let's do that. Let's start from 1,000. And it will still only take 10 guesses. If you have 1,000,000 answers, well, it only takes 20 guesses. And if you have 10 to the 9 or a billion, I think that's 10 to the 9. I always get confused about a billion. But if you have one with 9 zeros afterwards, that will still only take 30 guesses and it will get the right answer. That's super fast, and it's a really good strategy. So if you can break a problem in half, then that will save you a lot of time in your programming challenges. This works for all kinds of things like sorted lists. You can find your way through a sorted list by breaking it in half and saying, well, is my element before this element or after this element? If they're sorted, you can do that. So that's why I wanted to teach you the concept of a binary search. Now I need to give you a challenge. I don't think this is too much of a challenge, but I still need to get you thinking of proper challenges at some point. I want you to tweak this code so that instead that it does do random search, but you keep in mind the highest and lowest. So instead of searching halfway between, you always search, you choose a random number in that range. So you'll need to use rand.inten, and you'll need to use the method, the inten method, and you'll need to add something to that, but I'll let you work that one out. So that instead of always starting at 50 and then going to 25 and then to 37, or it will be 12, I think, the other end, it goes in the right direction. So please give that a go. As I said, don't forget to like and subscribe. Follow the lesson. There will be another lesson, and I think next week, we're going to learn about packages. We're going to move some of this stuff into packages, and we're also going to use an array. So that's a way of storing lists. So hopefully that will get us started. Have a good week.